I think, all right, that's better. I thought it was too easy. I didn't hear the echo coming back. All right. So what I was saying was, when we started Windows 10, we took a look at what it would take to bring those cutting-edge experiences to life across a wide range of hardware, everything from the lowest powered Raspberry Pis up to the highest powered medical imaging devices. What we realized is we needed to build a new platform for our new foundation for our UI platform. That new foundation is the visual layer that we'll be introducing a little bit more today. We'll walk quickly through some of the key concepts, then we'll talk about the capabilities that you can use from the animation system and the effects pipeline. And finally, we'll wrap it all up with talking a little bit about what's to come and how you can help shape the future. Now, the first thing to understand is where this new visual layer fits into the system. And it fits in between the framework layer and the graphics layer. We expect most apps will want to start with something like XAML. It does a lot of the heavy lifting for you. It provides services like data binding and accessibility and layout. But there'll be times when you want to get a little bit more flexibility and control, and the composition APIs are designed for just that. These APIs have also been designed to work with the graphics layer, so that when you need full flexibility and the power of the platform, you can drop all the way down and use that as well. Now, hopefully you guys had a chance to watch James's talk yesterday, where he covered a bunch of these concepts in more depth. We're going to fly through the rest of them very quickly, but if you haven't checked out James's talk, I highly recommend that you go see it. So what does the visual layer deliver? Well, the first thing is the visual layer is built on a unified compositor that powers your universal Windows apps. This enables you to build a continuum of experiences across all the one-core device families. It provides new capabilities from lightweight visuals to a new rendering engine, effect system, and animation system, enabling you to build great user experiences. All of these have been optimized for high scale and highly dynamic content. And then last, we've taken these new capabilities and we've wrapped them all up into a WinRT programming model so that you can use them from both C++ and C#. Now, not surprisingly, the fundamental construct of the visual layer is the visual. Now, visuals all support things like positioning, clip, and opacity, but there's also specialized visuals for displaying content. Things like solid color, image visuals, and effect visuals. We'll talk a bit more about the effect visual when we talk about the effect pipeline a bit later. The last type of visual that's worth talking about is the container visual. This allows you to create parent-child relationships and to be able to create a tree of visuals. Now, an important thing to note, and this is something that's going to be a resounding theme throughout this talk, is that there's more types of visuals coming. This is just the first set. You can see a few examples of some of the things that we're thinking about here. The last concept I want to touch on is where some of these different objects and things execute. So when you go ahead and create visuals, define your effects, and run animations, you'll do so within a compositor session. After you've done the set of operations, a commit will occur, and then within that compositor session, the set of operations will be optimized. So for example, if you moved a visual and then moved it back before the commit occurred, that'll get optimized out. Once we have that optimized list of operations, we'll go ahead and marshal those over to the system compositor, and it's here where the visual tree actually lives and where your effects and animations actually execute. What this means for you is, even if your UI thread is busy, you will still be able to deliver a smooth, seamless experience to your customers. All right, so let's get into the actual animation system. Let's start with a demo here. All right, what you're seeing here is a simple app that we put together just to illustrate some of the features of the animation system. This is keyframe animations that are driving the position and opacity of the clouds, as well as the rotation of the rays of the sun. As you see me pan over with my finger here, you'll see that the background color changes. Now, this is a great example of where we're actually calculating a value on the UI thread, pushing it over the compositor, and then driving a subtle effect. The fact that it's a subtle effect is important because if your UI thread does get busy, you want to make sure that it doesn't leave seams in the experience for your customers. Now, the next thing that you'll see here is the rain. It's the most interesting thing here. So what you'll see is that these are actually using a new feature called expression keyframes. And as these clouds are moving, the raindrops are actually starting to fall directly from those clouds are. But it's a little bit more powerful than that. These keyframes are actually referring to variables that are only known within the compositor. So for example, let me say that I go ahead and up this wind here. What you'll see is that the already scheduled and already running animations are updated. No new animations were applied there. Now, being from Seattle, I've come to love the rain, so let's go ahead and crank up the rain. So what you're seeing here is 1,000 different raindrops. That's 1,000 visuals and 1,000 animations that are being created and destroyed every second. This gives you an idea of the type of scale that we're striving to achieve so that you can build great experiences and rely on high scale for your customers. The last thing I want to show you here, I just want to touch on really quick. And this is an animation that is actually driving the effect system. This is important. So this means that these two systems are not designed separately. The animation system is designed to work with all of the properties and all of the objects that live inside the composition API. Now, the next thing that I want to show you is the Memories app. And this thing illustrates something interesting. It's actually using XAML, the XAML animation system in concert with the new visual layer animations in order to achieve an experience. Oh, hang on here, let me restart that. So the first thing to note is this intro animation. And you see it go ahead and slide in nicely and the text appear. The other animation that I want to show you is the photos actually lifting up off of the page as I pan. Now you'll notice that the effect is actually static. It doesn't matter which direction I'm panning or the speed. The next step is to actually wire up input into this app and the velocity of panning to actually change the amount that they float off. So let's just go back to the slides and talk a little bit more about what you just saw here. So there are 3 types of animations that you have at your disposal. 2 of those you got to see in the Memories app. The one you didn't get to see are XAML transitions. These are implicitly triggered animations that happen when certain actions or state changes occur. The intro animation that you saw was actually an example of the XAML storyboards, and these are explicitly triggered animations that target XAML objects and properties. Now, the interesting thing to note is that in Windows 10, these are now powered by the compositor. This means all the work that we've done in order to tune the system and make it higher scale and more smooth, you get largely for free with your existing code using XAML animations. The last one are the visual layer animations. So these are explicit lightweight declarative animations that are designed for performance and scale. We're going to spend the rest of our time talking about these, but before we move on, I want to talk a little bit about where you want to keep using XAML storyboards. So the first place is if you're trying to style a XAML control, or you need to integrate with the Visual State Manager, you're going to want to keep using XAML storyboards. Another place is if the motion that you're trying to define is fairly simple, you probably want to start with XAML storyboards, as there's a set of stock easing functions that will help you to get the ball rolling faster. And then last, if you want to define your animations in markup, or you want to use the design time tooling support, XAML storyboards will be the way to go. Now, these are all areas that we're hoping to improve in the future, but at least for the near term, this will be a good way to get started. All right, so what are some of the goals of the animation system? First, everything can and should animate. Now, this is a bold statement, but what it really means is that there should be no jitters, jumps, or pops in any of the experiences that your customers get. Now, with what we're delivering today, we're closer to really what should animate, can animate. But we'll be looking to add more features to be able to tackle the more complex scenarios more easily. So for example, adding implicit animations for when content comes in and out of the tree. Another thing is we wanted to make sure it was easy to find complex relative motion. And this really means two things. The first is that it should be easy to precisely define the look and feel of the motion that you want. But it goes beyond that. We want to allow you to define animations that go beyond just time and allow you to use the inputs from other properties and objects to be able to define the motion on others. And then last is performance. Once you have the animations that you want and the look and feel, and they're being applied everywhere, we need to make sure that your app remains beautiful and smooth, even at scale, so that your customers get a great experience. So let's jump into some of the actual features. The first are basic keyframes. If you've used other animation systems, this will be a very natural and intuitive thing. So I just showed the blue box moving. It's a common thing that you might try to do with a keyframe animation. If you've used the other ones, you'll know keyframes are usually made up of 3 different things. You've got a time for when the keyframe should occur, a value, and then the easing function that allows you to go from the previous value to the current. In this example, we're using a cubic Bezier for the easing to get that ease and out feel. And then the only other thing worth noting here is that the time that we're using on that keyframe is actually a relative time. So this allows you to define the shape of the motion that you want. And then by using the animation.duration property, you'll be able to go ahead and stretch out that animation for different feels. All right, so let's get into something that should be new, expressions. So in Windows 8 and 8.1, there were several experiences that we built into the platform that relied on a component to calculate a transform, and then to use that transform as input to calculate a second transform. And then it needed to set those 2 at the same time. For one example of this is actually just the basic scroll bar. As a user is panning along, you want to make sure that that scroll bar moves at the same proportional rate. Another good example is sticky headers in a grouped list view. As the user is scrolling along, you want that header to stick on screen so that the user has some information about what they're looking at. And the last thing I want to show you is some parallax examples, starting with the most simple and moving up to something more advanced. And this gives you an idea of how this simple concept of using something other than time is a really powerful tool to bring your app to life. So the jitteriness you're seeing here is just because we're using a mouse wheel. This was the basic case where the foreground is just driving a ratio onto the background. This gets more interesting as the offset of the foreground is now driving a rotation, and that watermark in the background is being blended together. But this one's my favorite. This one is where a 3D transform is getting calculated and is actually getting put onto those background elements to give a real feeling of depth to the experience. All right. So expressions, I mentioned this word. What exactly are these? So let's walk through 3 simple code snippets to be able to figure out what they are and how you can use them. So the first is simple parallax. So as you can see here, simple parallax is just taking the offset of the foreground and multiplying it by a parallax ratio. An expression is nothing more than a set of vector math operations that take some set of inputs and then map them to a single output. Another example we can look at is the basic adorner. So let's say that you have an object that's 250 pixels wide, and you always want it to be the left of some selected object. Well, there's 2 ways you could do that. You could put the objects side by side, and every time you moved one, you need to move the other. But a better way is just to describe the position of that adorner as being 250 pixels to the left. And that's what that expression does there. This is an example of where we're using some of the constructor methods to be able to actually create a constant in the expression. But you could also put parameters into that constructor so that you can create more complex types. And the last example I want to talk about is fade out over distance. And this actually shows 3 different concepts. The first is that there's a set of helper functions that more easily let you define the motion that you want. For example, there's things like clamp and absolute value. Another thing that it illustrates is a set of keywords that actually get evaluated either when the animation is connected or continuously throughout the execution of the animation. So for this example, there's 2. There's this.target and this.starting value. The starting value refers to the value of the property at the moment the animation starts playing. And this.target actually refers to the parent object that actually owns that property. Now, this.target's not available yet, but it will be coming out shortly in a new flight. The last thing that this thing goes ahead and shows you is an example of swizzling. So you see there that we're actually referring to offset.x. Swizzling really refers to being able to source from a property or from a subchannel of a property. We think about swizzling in the same breath as masking because they're really two sides of the same coin. Masking is about being able to target subchannels of the property. Now in this example, it's extremely simple. We're just referring to X, but more advanced things are capable, similar to what you might find in HLSL. So we talked a little bit about the fact that the animations are running independently of your UI thread. And this allows you to get great, smooth experiences for your customers, even if your UI thread's busy. But what happens if you start an animation and you suddenly need to interrupt it? So for example, maybe you have data virtualization and an object's animating and another one comes in before that animation completed and you need to go change the animation on it. So how do you avoid the jump and the jitter? The answer is that you can combine expressions and keyframes. Expression keyframes were designed to solve this scenario and more. So let's walk through 3 simple scenarios. So what I'm showing here is actually the default first keyframe. If you don't specify any keyframe for time 0, you will get this .starting value. This means that if you interrupt something that's already in flight, you'll get a perfect smooth handoff between those animations. If we go back to the adorner scenario, what happens if that adorner needs to move between objects, or it starts in one place and then connects to an object? Well, the way to go ahead and do that is to define that the last keyframe is actually 250 pixels to the left again. This means even if that object moves while the animation is playing, the running animation will be updated, and it'll finish next to the object. And the last example I want to talk about is animation reuse. In the Memories app, you actually saw an example of this. All of the animations were actually defined up front. Then, when it was time to go ahead and execute them, the definition was just grabbed, tweaked a little bit based off of whatever we wanted to specialize for that object, and then connected. This allows you to go ahead and create the animation up front, reuse it, and not have to pay the cost of recreating them every time. And with that, I want to invite Jeff up, our architect, to show you how you can use these features to build a beautiful app.
Hello, everyone. My name is Jeff, and I'm really happy to be here today. I get to introduce you to the new animation and effects stuff that Nick has been talking about in our Windows UI Composition API. To do this, what we're going to do is we're going to take an existing application that we've already written, and we're going to add various animation effects and show how easy it is to make it visually interesting and beautiful. So let's take a quick look at our final result of what we want to achieve.
Switch your slide.
Yep. Thanks. So this is a slideshow application. It has a bunch of different tiles, and each tile is displaying a different photo. There's a selection of different types of transitions that we can apply. So for example, in this case, we've gone and desaturated all the different images, and we did it smoothly with animations. Now we're going through and we're applying a flashlight of color in the very middle. And again, this is all running using our new APIs. So is there an echo? No. Let's take a quick look at where we're starting from. All right. So what you'll see is we have an existing XAML application. This application is using the Windows UI Composition APIs to create a bunch of tiles and display the photos, but there's no animations and there's no effects currently being applied. So we'd like to start off by adding some movement to each of these tiles. What we're going to do is we're going to slightly rotate them from side to side. This is going to demonstrate how to use keyframe animations and also the scalability of our system, because there's 400 tiles right off the bat. So to understand a little bit about the system, basically we're being hosted inside XAML, and then from XAML we get our container visual that we're going to put everything inside of. Under that container visual, we have a panning visual that we put all the individual tiles. For each tile, we have 3 more visuals: a frame, which is the background white solid color, an optional selection, which is the orange that you see that fades in and out, and a photo. So we're creating probably about like 2,000 visuals right off the bat. So let's go and add the keyframe animations to the frame, those white solid color frame. So to do this, what we're going to do, it's pretty simple. We're just going to create a scalar keyframe animation because the rotation angle is a float value. We will insert a keyframe at the very end of the new angle, specify a duration, and connect the animation to the desired visual's rotation property and start playing on the composition property animator. So let's take a look at what this looks like in code. So what we see here, we have our constructor for each of the individual tiles, and we have this function, start new rotation animation, that we're going to go and fill in with an implementation. So what this is doing is it's calculating a random angle between -10 and +10 degrees. It's then creating the scalar keyframe animation because we're going to modify a float value, and then we're going to, at the very end of that animation, because the progress goes from 0 to 1, we're going to specify the new angle. We'll then calculate a random duration between 2 and 5 seconds, and then we will, on the frame, which is the white solid color background for the individual tile, we'll connect the animation to the rotation angle property, and we're going to store the composition property animator because we're going to end up using it a little bit later. And then we'll kick off the animation. So let's see what this looks like. So this is running on a 3-year-old laptop. It's not a very powerful system. It also gives you an idea of the type of scalability that we're seeing here. So as you can see, we loaded all the tiles and we kicked off all the rotations, but when those rotations completed, they stopped animating, which is what we would have expected. We could have done something like creating an infinite duration on these animations, but then they'd be going back and forth between the same angles and it would get sort of monotonous. Instead, what we'd like to do is, when the first animation completes, we'd like to kick off a new animation using a new random angle. So this shows how to do this. We're going to use the animation events on the composition property animator that got returned back when we connect the animation. We're going to listen to the animation ended event, and then we have to subscribe to that before we call start. If we were to subscribe to it after we called start, then it would be applied the next time we connected. So what we're going to do is we're going to slightly modify our function here. So start new rotation animation. Because we're constantly creating and destroying animations, what we want to do is explicitly dispose the previous animator before we connect up a new one. This frees up system resources more aggressively, and it gives us better performance and scalability to allow us to run on lower-end hardware, such as a phone. The code that actually builds the keyframe animation is identical, and that connects it is identical. The only difference is that we've now added the animation ended event and started it. In the animation ended event, we'll unsubscribe from the event because we only expect it to get fired once. And then we're going to, again, kick off a new rotation. So let's see what this looks like. As you can see, all the tiles are loading, and they're rotating. Once they complete one rotation, we immediately kick off another rotation, so everything's now moving in the background. This demonstrates about 400 animations running consecutively, And there's no CPU usage really being used on the system at all. It's very scalable. So what we'd like to do now is add even more movement. So the panning visual that all these tiles are parented under, we'd like to start moving it around and scaling it in and out. This is really going to add a lot more visible movement. Now, one of the things that we want to do is not just create animations, but we'd like to create a transition library where we have a variety of different transitions, and then we can just have a design team go and create different types of transitions and different animations and make something look visually beautiful, and then have the development team easily go and pick one of the transitions out of that library and start it playing. To do this, we're going to solve two problems with one set of code. What we're going to do is when our application starts, we're going to go and we're going to define all of our keyframe animations that we're going to use. And you'll notice that we're using the expression keyframes that Nick talked about earlier. Merely by using this MyScale parameter automatically declares it. You'll notice in this first section of code, all that we're doing is declaring the animation, but we're not immediately hooking it up. At this point, the animation will be sent over to our composition service, so it's already ready and available as soon as we want to kick it off. This helps improve performance and scalability and helping to build responsive UIs. At the point that we're actually going to create this particular transition, all that we have to do is fill in the MyScale parameter that we previously declared with the final value and connect the animation to the target's property that we want to animate and start it playing. So let's take a look at what this looks like in code. This function here only gets called at the beginning of the application startup. So it's going through and building a variety of different animations that are used for different transitions. So let's provide some animations that we'll use for a zoom transition. In this case, just one second. That's where we want. In this case, what we want to do is we're going to define 3 different keyframe animations. We're going to define one for setting the scale, one for controlling the center point, and one for controlling the offset. The reason that we're setting the center point is by default it's in the upper left corner of the visual. And rather than when affecting the scale in the lower right corner, we really want the panning visual to scale from center. As you can see, we're setting a variety of different parameters, including my scale, my target center point, and my viewport center. What we're going to do also, we're going to just put a breakpoint here just so that we can validate that this really is only called once. This function is then called when we happen to pick the particular zoom and pan transition. So we'll go fill in its implementation. As you can see, all that we have to do at this point is use the previously defined keyframe animation, and every time that we use it, we're going to specify different values for the parameters that we declared previously for my viewport center, my target center point, and my scale. Now the cool thing is that because we have a transition library and we have different types of animations, we can actually use these same parameters across different animations, and then once we pick them and apply the parameters, we can really start mixing and matching different things. After we configure the animations, we'll again connect them to the panning visual's various properties, and then we have a little transition class that's part of our application that we use to keep track of everything. So we'll probably breakpoint here as well so that we can watch this get kicked off. Let's see this actually running. So as you can see, the create animation templates is going to get called once. We'll leave that breakpoint there just to verify everything. We'll then kick off a zoom transition. The create zoom and pan transition now gets called We fill in the individual parameters that we specified back when we declared the keyframe animations. We'll connect the animations and kick it off. This will immediately kick off the transition, and it's going to execute. When this transition completes, it's going to begin another transition, and we'll see our breakpoint hit again. So as you can see, we're reusing the same keyframe animations that already exist over in the composition service. We don't have to send them down again, and this helps improve with our performance and scalability. So at this point, I'd like to bring Nick back on to continue talking.
Thanks, Jeff. So ever since we introduced Windows 8 apps, you guys have been asking for support for effects. Now, it's taken us a little while because we wanted to think about how to do it right and performantly, but we have listened. I'm proud to introduce today the new effects system. So let's start off with a demo. All right, so this demo is a very simple one. It just showcases a few of the different effects that you have at your disposal. The first one here, we are animating a color that is then being blended together with this photo. In this case, we're using the mode hard light. The only thing that we've changed between the last one and this one is the photo, as well as the mode. And so in this case, we're using hard mix. Another effect that you have at your disposal is saturation. And so this is where you're seeing the saturation being animated from a fully colored image all the way down to a fully monochrome one. Here you're seeing a crossfade effect being accomplished using an arithmetic composite. And there's one more I want to show you here. This last one is an animated composite effect in order to get this animated alpha mask type feel. We'll actually walk you through a little bit later in this talk about how you can build up this graph and use it in your apps. So now let's go ahead and jump back over to the slides. So let's start with the goals for the effects system. The first thing is that when it comes to effects, performance is paramount in order to deliver a great user experience. The system has been tuned to deliver real-time effects and real-time blend modes operating at 60 frames per second. Another thing is if you've worked with effects with UI, images, or video in the past, you'll know that there is different ways of describing the same effects depending on which medium you're using. In Windows 10, we're converging on a consistent API where we'll use the Win2D effect descriptions. Win2D is the new WinRT wrapper around Direct2D. Simon had a talk yesterday, or I think actually 2 days ago, where he introduced Win2D. If you're interested in that, I recommend you go check it out. Now, the composition APIs and Win2D have been designed to work together, but these subsystems have different goals. Whereas Win2D runs in process, is immediate mode, and is designed to give you full control over your drawing, the composition APIs run out of proc, are retained mode, and are focused on real-time effects and great user interfaces. Now, in order for us to guarantee a user experience, both for your apps and the system as a whole, we're focusing on a subset of the Win2D effects. So let's take a look at what they are. The first one is arithmetic composite. In the demo, you saw that being used in order to do the crossfade. There, we are simply animating the source 1 and source 2 amount. Another effect that you have at your disposal is blend. There are actually 21 different blend modes that you can use. This example here is using hard mix. Saturation is another one. Here you're seeing an image going to 0 saturation, so it's fully monochrome. And the last one is composite. There are 13 different composite modes. We were using destination in order to create that alpha mask. Now, the key thing to note is that this is just the initial set. We are being deliberate and mindful about which effects that we bring on because we want to make sure that you guys can trust the effects to be able to use across the broad range of hardware to build the great experiences for your customers. And with that, I want to invite Jeff back up to show you how to really make that app beautiful.
Thanks, Nick. All right, so what we'd like to do is we're going to take our application, and I'll just do a quick thing just to remind everyone where we last left it. So we're loading all of our tiles, and we're applying a bunch of different keyframe animations on both the tiles, and once we kick off a transition, on the actual panning visual. We're modifying offsets, scales, center points, and various things like that. But all these tiles are fully saturated, and it makes it sort of difficult to draw the user's attention to the tile that we'd like them to focus on. So what we're going to do is we're going to use the composition effects that Nick just talked about, and we're going to desaturate all the tiles except for the one that we want to draw the user's attention to. So to set up our saturation effect is pretty simple. With effects, there's three key parts. There's the effect description that we get from Win2D. That's converged across the entire system so that you can use the same effect in drawing, in composition, and eventually in media. From the effect description, you'll build an effect composition, or you'll build a composition effect factory. What that does is it compiles the effect and sends it down to the composition service. From the composition effect factory, you'll then create individual effect instances for every different combination that you want to use in the effect. In this case, we're going to be using the saturation effect. So let's take a look let's see what it looks like in code. So previously, we were using just image visuals to display the image. We now want to change those to use effect visuals because we want to actually display effect instances. So what we'll do is we'll replace the image visual with the composition effect factory, the effect visual, and the specific composition effect instance. You'll notice that the composition effect factory is static because it can be shared across all the tiles, but the composition effect is per instance because each tile is going to need its own instance because it has its own image. This initialize function gets called at the very beginning of the application, so this would be a great time to go and create our effect factory. We'll create our effect, we'll use Win2D to create our effect definition, and then we'll start off initially with an effect that doesn't animate, so we'll just say that it's fully desaturated. And then we'll specify that the effect source parameter is, the effect source is a parameter that we're going to just call image, and then we'll create the effect factory. And one thing I forgot to show is we also have to add Win2D to the project references in the solution. I've already done this. You can see that it's Microsoft Canvas or Microsoft Graphics Canvas, but if I wanted to go and add it, all I would do is go to Manage NuGet Packages, go to the standard NuGet repository, type Win2D, and click Install. And then this would really easily go and add a reference into my package so that I could go and use it. So at this point, I have my effect factory, but I'm not able to display an effect. So one of the things I want to do is, like before, I want to clean things up when I'm done. And this is just, cleaning up the objects. Okay, this is where we're going to get to the heart of the thing. You'll notice that previously we created an image visual, set the image, and configured it. This particular property gets called by our application once an image is available. What we do is we create all the tiles up front so that we can go and lay them out, and then we go and kick off all the images loading. Because they're loading off the file system or over the internet, it takes some amount of time for the images to arrive. When the image arrives, we then assign it to a particular tile to display. That means that there's a period of time before the tile's displaying anything. This function or this property gets set once the composition image arrives. So what we're going to do is, this is a great time to go. We will, from our effect factory, we'll create the effect instance. and then we will set the image parameter to the composition image that's just been loaded. We'll then create an effect visual to be able to put it into our overall scene graph to be able to display everything, and we'll set its effect. So let's see this actually running. So what you'll notice is that all of our images are now desaturated, including the selected image. This is something that we could have done at load time when using Win2D or other system services to just apply on the image. So it's not exactly interesting. What really is going to get interesting is when we start animating the thing. So let's go and do that. Now, when we start animating effects, one of the things that's important to understand is that the effect is actually a graph of nodes. And so within that graph, if I want to animate a particular property, I have to specify the fully dotted path to the property that I want to modify or animate. Why this matters is that, for example, I could have a crossfade that goes between two desaturated images. If I want to modify the saturation, am I modifying before's saturation or after's saturation? That's why we're going to have to name all the nodes that we want to modify. So our initialization for creating the effect is pretty straightforward. All that we have to do is the nodes that we want to animate, give them a name, and then when we create the effect factory, we give a list of all the fully dotted paths that we want to animate. This is part of our overall philosophy at the visual layer. What we want to do is pay for play. So we need to know what you want to be able to modify or animate so that we know to create variables in the shader rather than constants. If we just created variables for everything, then you only could run on the highest end hardware and the shaders would actually execute pretty slowly. By doing it this way, where you declare up front what you want to be able to modify, this allows us to create the most optimized shader to run on the GPU. At the point that we're going to connect the animation, we connect it to the fully dotted path on the effect. Now, people in the audience may notice that what's this properties object that's hanging off of our effect? Well, the short answer is that when it comes to the composition system in animations, we have properties and we have parameters. Parameters are things that you don't animate. They're things that you just directly set. And properties are just regular WinRT properties on composition objects, and these are things that can be animated. We have a lot more information on MSDN to describe when you use these differences. For right now, what's important is to understand is that we're connecting it to the properties because we want to animate it. So let's see what this actually looks like in code. So in this case, what I'm going to do is I'm going to modify my factory to create an animatable effect. And I'll remove my previous definition here. So pretty straightforward. All that I have to do is put the name and then put the fully dotted path to the property I want to animate. I'll declare my animator. I'll clean things up. Now this function is the function that gets called from our transition library to actually apply a desaturation effect on this specific tile. This is where it's going to actually connect an animation. So let's provide the standard implementation. And we're going to put a breakpoint here so we can see it getting called. If I had a previous animator, again, I want to go and explicitly dispose it to free up resources. And then remember that I don't actually create the saturation effect instance until I get the property, but I may actually, the transition library doesn't want to keep track of that all, so it will just call this function even before the photo is loaded to update as part of updating the saturation value, or whether it should be saturated. All that I do then is I connect the animation to the fully dotted path of the saturation, and I start it playing. The final thing that I do is I'm back in the photos setter, and what I'm going to do is, this is where I will directly set the property on, I'll directly set the saturation effect property at the time that I load the photo. The idea is that I create the tile, I might tell the tile that it's desaturated. When the photo arrives, I want it to immediately jump to being fully desaturated or fully saturated, whatever is appropriate. I don't want to actually show an animation in this case. So let's see this actually running. So we can see our apply desaturation function got called. We didn't have a previous animator in that case, and we don't currently have a saturation effect. So we're going to move our breakpoint into here. I hit F5, ran it again. This time, I actually do have a saturation effect instance. All I'm going to do is connect the animation and start it. So what you'll notice, keep an eye on whatever photo has the orange around it. We want it to be fully saturated. As we change the selection, this current photo, you'll notice desaturated using a smooth animation, and the new photo that got chosen was fully saturated. So rather than just turning something on and off, this is actually executing the animations in the composition service. And this is one of the key value propositions of our compositor. Because everything's animating and it's executing on our rendering thread, we're able to do things very smoothly and at much more scale than if I had to try to do this at image load time or in the application thread and be shuttling new data over to the compositor. So this is starting to look more and more visually interesting, but what I'd really like to do is kick it up a notch and put the flashlight in that we talked about earlier. So the flashlight, we're actually going to use the expression animations that Nick talked about earlier as well. And this is a pretty complicated expression, but it's actually doing something that's pretty simple. All that it's using is it's using Pythagorean theorem to basically compute this distance from the frame, you can see, and then from the frame of the individual tile to the center of the window. The further away it is from the center of the window, the more desaturated that we want it to be. It also is specifying a bunch of different parameters that we're going to use. Some of these parameters will provide initial values, such as the radius or the grid that we're applying it on. Other parameters, like the window offset or the window size and width, will provide right now, and then we actually also update these whenever the window size changes. So this apply desaturation function is part of our transition library, and this is the thing that we can see calls the apply desaturation animation that we provided in an implementation earlier. In this case, what we want to do is create an instance of the expression animation to hook it up. If the transition specifies to use the color flashlight, what we'll do is on the expression animation, all that we have to do is set the frame, the solid color white background visual that we want to apply the thing on, or actually, yes. And then we will apply the desaturation on the tile. So let's actually put a breakpoint here and watch when this gets called. So the first transition that got kicked off won't have the flashlight on, but then the next transition that gets kicked off should have it. Okay, so what we now are doing is we're applying the desaturation, we're specifying the reference parameter, and then we're going to call into the function. In this case, there wasn't a previous animator, and I'm connecting the animation just like before. So one of the things that you can see here is whether it's expression animations or keyframe animations, they're all just composition animations, and they all can be applied using the exact same APIs. So at this point, what you'll notice is that we have a flashlight of color in the center of the window, and whatever the selected frame is, the selected tile will also be fully saturated. Everything else is desaturated. Finally, we'll go through and we'll enable a couple of other different animations to fill out our application, and this is what we originally showed at the very beginning of what we wanted to build. Now, the really cool thing is that everything that we've demonstrated actually is part of the Universal Windows platform. And so the standard composition service and all of Windows UI Composition API is available not only on PCs, but tablets, phones, Xbox, anywhere else that the Universal Windows platform is available. To demonstrate this, what I'm going to do is I'm just launching the app. Just rotate it. So what you can see here is the exact same application running on a 3-year-old phone. It's running at 60 frames per second. I didn't make any lines of code changes. I didn't have to have multiple libraries that were being compiled. There's no pound ifs or anything else. It's the exact same thing, compiled for ARM, deployed on phone, running at full frame rate. And with this, I'd like to invite Nick back to continue talking about more advanced effects.
Thanks, Jeff. So one of the things that Jeff hinted at was the fact that effects are actually effect graphs. And so there's actually 2 more types of effects that I didn't talk about earlier. The first one is color source, and the other one is transform 2D. Now, on their own, these effects are not that interesting. But when you start to be able to take the output of one effect and use it as the input to another, they become very useful tools. So let's take a look at a simple example of where we might use this. So let's say we start with this full color image, but what we want to end up with is this pinkish purple one on the right. We'll do that by creating 3 effects. The first one is saturation, that will take it all the way down to a monochrome image. We'll use a color source in order to create the pink color, and then we'll finally blend it together to get the pinkish purple color. So this is a simple example of how you can start to combine the different effects to really customize your UI. So I mentioned earlier during the demo that we would walk through how you can build this animated alpha mask. This is an example of how we can take all the pieces and put it together. So there's 5 different steps. The first one being we need to define the effect. Now we're going to use the destination in, and there's 2 sources that we'll need, the image and the mask. If you watched James's talk yesterday, he was able to stop here because he just wanted the static alpha mask in order to cut out the profile pictures. We actually want to be able to animate a transform of the masks, so we'll update our definition. You'll see that we have added the transform 2D. It is now the source, and then the mask moves to be the input to that effect. We've named this node mask transform so that later we can go ahead and animate it. We'll go ahead and set that up now. So you go ahead and you call the create effect factory to compile the effect. You pass in the description, and then you specify which of the properties you want to be able to animate. Once you create the effect, you actually have an instance that has 3 inputs, the image, the mask, and the mask transform.transform matrix. We'll go ahead and set those. You've got the image and the mask that we just go ahead and load up images for and set. And then finally, we connect an animation to that mask transform.transform matrix. And then last, it's very simple. We need to apply it, so we create an effect visual. We take the mask effect, and we set it on there. Now, this is a great example of the 3 different axes that you have in order to customize your experience. You have a set of effects that you can use, including the 21 different blend modes and the 13 different composites. You can take the output of one effect and use it as the input to another. And then finally, you can animate those inputs. This gives you a ton of flexibility in creating great experiences for your customers. I want to wrap up a little bit with where we're at and where we're going. So first, what do we talk about today? The new visual layer is built on top of a converged compositor that powers your Universal Windows apps. It allows you to create a continuum of experiences across the entire breadth of the one-core device families. We talked about new capabilities, both within the animation system and a brand new effects pipeline. Both of these systems have been optimized for high scale and highly dynamic content so that you can trust it and build great experiences for your customers. And last, we wrapped all of these capabilities up in a new WinRT programming model so that you can use it from C++ or C#. Now, everything that we showed you today is available for preview in the Insider builds. It should be made fully public by the end of the year. This is just the first few steps, though, on our journey. We've got more ideas for where we want to go. Everything from creating new classes of animations, to improving our interrupt story, to expanding our effects library. But where we go next is largely up to you. We want to build the things that will have the biggest impact on your business and will help you excite your customers. So please send us your feedback. Take this journey with us. It's a journey that we can't do without you. By giving your feedback, you'll help shape the future of composition, and you'll be able to make sure that we build the things that you need most. So you can connect with us on Twitter, or you can catch us on email. There are a few different resources that we talked about today, including 2 talks that I mentioned. The one I didn't talk about was on API contracts, which is actually going on right now. You'll want to check that out, as Brent described how you can use feature detection so that you can build a single binary that takes advantage of platform capabilities conditionally so that it can run across Windows updates. There's a few links that we have here, including a link to the samples that will be up on GitHub. And once again, reach out and connect with us. We want your feedback. It'll be really useful, really helpful for us. Finally, if you can, please take the time to go ahead and evaluate this session. This is really great feedback. It helps us both to improve as speakers, as well as to make sure we bring the right content to you guys year after year. Jeff and I will be down at the Insider Lounge if you guys want to ask any questions or if you just want to chat. Thanks very much.
Thanks.